Okay, good afternoon, class. So this week we'll be discussing homework number one, right? So this has been already uploaded on, the solution has already been uploaded on Moodle. So let's start discussing this. Right? So question number one was to classify the following signals as either continuous time signal or discrete time signal or digital time signal, right? If not classifiable, make the necessary specifications. A, music information read by a computer from a CD-ROM. So what do you think?
Digital.
It's digital. Okay, the solution is there, isn't it? Okay. Okay, yeah, it's digital, right? You might have learned this in CS211 as well, right? Um, Regarding the sequential reading of the CD-ROMs, right? Temperature in the room measured by a thermometer, right? So temperature uh, measured in a room using a thermometer is basically continuous, right? Because it doesn't say that you are measuring time to time. It is just temperature in a room measured by a thermometer. So if you just leave a thermometer in a room, what happens is that it will continuously measure the temperature, right? Signal recorded by seismogram. So again, signal recorded by a seismogram. You know what a seismogram is, guys?
It's an earthquake instrument there.
Yeah. So seismogram, if you leave it on, right, it will start. It will keep on recording the motion of the ground, isn't it? So
Yeah.
same way. So it is continuous again, right? Your exact weight measured every day at 7:30 a.m. So you measure your weight today, you measure your weight again at the same time tomorrow, and so forth. So you are basically taking particular point, particular weight at a particular time, isn't it? So it's signal. Okay. So I believe you have already covered this in your DSP as well, continuous time signal, discrete time signal, and digital signal, right? So let's move on to question number two. Question number two is to determine whether the following signals are periodic. If they are periodic, find the fundamental period. So do you think this particular question number 2A, do you think this particular signal is periodic? Let me see. Emily, do you think this particular signal over here, question number 2A, is it periodic? Zeo, what do you think? Is it periodic?
Yes, sir.
Uh, Actually, it's not periodic, okay? Because it's not continuous either on the negative side or on the positive side, right? It's bounded, right? It is bounded by values of 5 and -5 over here. So the k value is actually bounded. So the signal does not keep on repeating uh, itself, right? So after a certain point, it just stops, right? Let's say after 5, if you substitute the values after certain value, right? When you substitute 5 in this particular equation or -5, after that, any values of k is equal to 6, 7, 8, or either the negative values of k, where k is equal to -6, -7, -8, and so forth, it has a zero value, okay? So it is limited, so it is not continuous, okay? It's not periodic. If these values of 5, these values of k went there, right? It wasn't bounded. It would have been it would have been a periodic function, right? With a period of 2. For B, you can see k value is not bounded, isn't it? It keeps on repeating itself, right? So this particular signal keeps on repeating itself continuously. It keeps on repeating forever, okay? On the positive side and the negative side itself, right? So it is periodic, okay? And it has a period of 3. For this particular case, in this particular case, after a certain point of time, the graph will turn flat, right? It will be just 0 on both positive and negative side. But for this one, for B, the same signal will keep on repeating itself, okay? That's the thing. That's the main difference, right? So in this particular case, if it keeps on repeating itself, it becomes periodic, okay? In this particular case, it is not periodic, okay? But this is, I mean, E has a period of 3, right? Okay. C is a periodic. You can see there's a continuous dot on this particular side and a continuous dot this side as well. Okay. What that indicates that the signal keeps on repeating, right? Whatever you have, it just continues. So you can see there's a pattern 3, 2, 3. I mean, like 1, 1, 1, 0, 0, 1, 1. Okay, and then 0, 0, 0. And then again, this same signal over here, this particular part, repeats itself over here. And then it repeats over here as well. So the period of this particular signal over here is how much? How many samples? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the period of this particular signal is 10. Or you can just pick one point, right? Let's say if we start from, like pick this particular point. So after how many points will this particular point repeat itself? So that is 10, right? You start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So that's how you determine the period of this particular sign. This particular graph, right? So the period of this particular signal that is given over here is 10. Okay. D is the signal periodic, right? Do you think it is periodic? Anyone?
No,
Why?
no sure. Because we have a change in signal at the initial point at 0.
Okay, yeah, right. This is just totally different compared to all the other points, right? If this was reflected upwards, right? If this particular part, rather than being down, if it was it had a value of 1, it would have been periodic, isn't it? But at the moment it is reflected down, it has a negative 1 value and it does not repeat anywhere else, right? So that means this is a non-periodic signal, right? You can see the solution. First one was non-periodic, this one. The second one was periodic, right? Like I said, this one was periodic with a period of 3. And then C over here, XFM, I said this it was periodic with a sample of 10, right? So it was the fundamental period was 10 samples. D, again, like you said, like Rico said, it is non-periodic, right? Because of this particular point in this. Question number 3, evaluate the following function, right? So x1 of c is equal to rectangular function t minus 2, right? Times delta of t. So we already know that the delta t value, the delta function will only have a value at t is equal to 0, isn't it? Okay. So the delta function will only have a value at t is equal to 0. So all the other values, it will be having 0, isn't it? So what that means is that if we are multiplying these two signals, right, it will only have a value when t is equal to 0, isn't it? So if you were to plot this particular function, you would have plotted something like this, right? The rectangular function at t minus 2. So it would have had a the rectangular function would have looked like something like this, right? And it would have, the center of the rectangular function would be at 2, right?
-2.
At
And
positive,
positive,
yeah, at positive 2. So all of you know what a rectangular function is, right? You know what a rectangular function is? Okay, let me just quickly show you. Let's just check. This is a rectangular function. Just a quick recap, right? Let's just take this one, right? A rectangular function. The center of this particular rectangular function will be at 0, right? At x value is equal to 0, right? And it will send 0.5 towards the negative side and 0.5 towards the positive side. Okay, it will have a total width of 1 unit. Okay, altogether, because negative 5 and positive 5. So it will have a total width of 1. Okay, so that's how this particular function was made. And this t minus 2 indicates a shift of 2 units towards your right. So shifting the rectangular function 2 units to your right, basically taking the center of this particular function, right? This particular function, center is at x, I mean at t is equal to 0, and shifting it 2 units to your right. So 1, 2. So the center will be over here, and you'll get a graph or something like this, right? And then the delta function, delta t function, is it only has a value at t is equal to 0, okay? And we usually take that value as equal to 1, isn't it? Right? So rectangular, I mean, this function multiplied with this. So when t is equal to 0, delta t, I mean, delta of t multiplied by 0, right? So we'll be having 0 function altogether, right? This multiplied by 0 value over here will give me 0. And then for delta t, it is all 0 afterwards. So 0 multiplied by the rectangular function is going to give me 0. So the total multiplication of both the functions is going to give me 0. You can see these two functions are not even overlapping. So at t is equal to 0, we only have a value for the delta function, right? While the rectangular function has no value, isn't it? So 0 times 1 is basically 0, right? And then all these particular parts are 0 times 0. All this side is all 0 times 0, okay? And then at the rectangular function, where the rectangular function is situated, let's say, I mean, this particular point will be 1.5. So again, 1.5 times at t is equal to 1.5, sorry, we have a value of x of t as uh, as 1, right? So 1 multiplied by 0 again, so everything will be 0, right? So basically multiplying this function is going to give me a value of 0, okay? If you were to do it mathematically, so this is the mathematical representation. So we know that at t is equal to 0, we'll only have a delta, I mean, a value of this particular function at t is equal to 0. So basically setting t is equal to 0, right? When we set t is equal to 0, so we have rectangular function or pi function of, we set t to 0, so we will get it 0 minus 2. So that is basically the rectangular function at negative 2 times delta t, right? And the rectangular function has, I mean, the rectangular function has value of 0 at negative, at t is equal to negative 2, isn't it? So 0 multiplied by delta t is basically going to give me 0, okay? It is always best to directly uh, graph the, I mean, graph these particular functions and then multiply it to see what values you get, right? So you can see these two particular values. I mean, at each and every point you are going to get, when you multiply the values of both the functions, you're going to get 0. Okay. X2 of t is equal to u of t minus 1 multiplied by u of 5 minus t multiplied by delta t minus 3. Okay. So in this particular case, what we need to do is to graph all these functions. So this mathematical part is done, but we'll just try to get the solution using the graph. So u of t minus 1, what this indicates is that the u of t graph has shifted 1 unit towards the right. Okay, so it is going to start.
Right.
Right. So this is the graph. So 1 unit towards the right. So this is the graph, right? With the orange line. Okay, and it has an amplitude of 1. Okay, 1 is there. And then when you dot u of 5 minus t, so what does this indicate? Negatively indicates that the graph is reflected, isn't it? Rather than going towards positive side, it will now go towards the negative side. Okay, this negative t. And then this 5 indicates that it is going to start at 5. Okay, so it is going to be having the graph of this, right? This particular part. Okay, one I have just shown. Okay, so the graph of u of 5 minus t is something like this, right? Yeah, it should have changed the color. So let me just go back and change the color of it. So this is the graph, right? With a red line. Can you see that? Now, the next function is we have plotted this, we have plotted this. We need to plot delta of t minus 3, isn't it? So if we plot that, what this indicates that the delta function is usually at t is equal to 0, right? So that has shifted 3 units towards the right, isn't it?
Right.
Okay. So let's draw that. So that means our delta function will be somewhere here, isn't it? Now we start multiplying. If we start multiplying for all these values, you can see that this is 0. So 0 multiplied by any value is going to give me 0, right? So there is no value. It is basically we are going to get 0 for all this region over here, isn't it? Right? Now, again, the delta function has all this section is 0, isn't it? For the delta function, this side and this side is all 0. So basically what that does is the product of all the three functions will become 0 at all these places, isn't it? And 0 over here. So it is only going to have a value at this particular point at t is equal to 3. Okay. And that value will be delta t minus 3 multiplied by 1, right? The amplitude of this particular function, the red line, has an amplitude of 1. The orange function again has an amplitude of 1. So 1 multiplied by 1 multiplied by delta t minus 3. Okay. So this is what we get, right? So that means there is only one value which exists at t is equal to 3. So that is basically delta of t minus 3. Okay. So that's how you get this particular value, right? Delta minus 3. Okay. Again, pardon me, I forgot to, I said this wrongly. The delta function is actually continuous, right? It keeps on going at t is equal to 0 if we were to plot the delta function only. Okay, it does not have any amplitude. If you were to integrate delta function, it has a value of 1, isn't it? Agree? Right? Okay, anyways, let's move on to part 3 of this. X of 3 t is equal to integral of e to the power of minus 3 t multiplied by delta t minus 2, right? And it is integrated in terms of t, right? From negative infinity to positive infinity, okay? So now we know that this particular function over here, it is only going to have a value when t is equal to 2, isn't it? While all the other values will be 0, isn't it? Just because of this delta function. Okay. So what we do is we can directly substitute the value of 2 into this particular function over here, right? Okay. We know just because of this delta function that there will be only one value that will exist that is equal to, that would be at t is equal to 0. T is equal to 2, right? When this delta function, when you have delta of 0, right? It will only have a value when delta is, when you have, when t is equal to 2, right? Or the function will reach delta of 0, right? So in order to get delta of 0, right, the t value has to be 2. So what we can do is that now we know that there will be only one value that is at t is equal to 2. So what we do, we substitute the 2 value in this, right? Okay, in this particular function over here, the exponential function, right? So if we do that, we get e to the power of minus 3 into 2, right? And multiplied by delta of t minus 2, right? And integral of all this, right? Now, if we do this, you now get this particular part as, you can read this as a constant, isn't it? Okay, so that is how you get e to the power of minus 6. An integral of a impulse function, right, is basically equivalent to 1, isn't it? Or a delta function or an impulse function, the integral of an impulse function is basically equal to 1, isn't it? So we are going to basically get e to the power of minus 6 multiplied by 1, okay, which is basically equal to e to the power of minus 6, okay. Are you getting it? You just basically take this because it has no t now, right? You just evaluate this inner part, inner function, and you can get, I mean, the value of this particular function is just basically equal to e to the power of minus 3 into 2 multiplied by delta of t minus 2, right? Okay. And then you can take this e to the power of minus 6, right? This value over here outside because it does not have any variable t, isn't it? So you can treat it as a constant. So when you take this, when you take this or treat this as a constant, what happens is then you are just basically left with the integral of the impulse function, right? So the integral of an impulse function is basically equivalent to, okay?
So,
Yeah.
one question.
Yes.
So the value 2 is the value of t, not amplitude.
The value of 2 is, yeah, it's not the amplitude, it's the time, right? It's the value of t. Okay.
Okay.
Okay. Right. Let's move on to question number 4, right? Question number 4. A discrete time sequence x of n is defined as x of n is equal to half to the power of n times u of n. Okay. What is the value of x of n multiplied by delta n minus 5, right? So again, what we can do is we can either evaluate and see what is the value of this, or we can graph it, right? So if you were to plot these, right? If you were to, I mean, we can mathematically evaluate this, right? Based on these functions, right? This is like this is a computation that has been done, right? So let me just explain you how we get this, right? So based on this, we know that just because of this delta function, right? We will only have a impulse value, or we will only have a value when we have delta of 0. So basically, in order to get 0 over here, n has to be equal to how much? 5, isn't it? Right? So what happens is we don't have a value for the delta function, isn't it? So we don't substitute any value over here, right? We just leave it as it is because we know there is only going to be a value at n is equal to 5, right? We leave it as it is, right? So this basically indicates this delta n minus 5 basically indicates that we are only going to have a value at n is equal to 5. Okay, we leave it, right, as it is. And what we can do is substitute 5 in this test function, because this particular function x of n is basically going to give a amplitude, isn't it? We can evaluate that particular part, right? So in place of n, we substitute 5. So x of 5 is basically equal to, if you go back, right, you can see that x of n is basically equal to half to the power of n, isn't it? So in x of n, I mean x of 5 will basically read as half to the power of 5 multiplied by u of n. Okay, so we have half multiplied by 5, and u of 5 will be basically 1, isn't it? So half to the power of 5 multiplied by 1 multiplied by delta n minus 5. So this delta n minus 5 is basically going to indicate that we are only going to be having a value at n is equal to 5. Right? So if we evaluate this half to the power of 5, we're left with 1 upon 32 multiplied by delta n minus 5. Okay. If we were to plot this, right, if we graph it out, we are going to get something like this, right? Okay. Is that right? It is going to have an amplitude at of 1 upon 32, right? At n is equal to 5. Okay. Now going on to the next value, I mean, on the next part of this particular question, it says what is the result of the summation of x of n multiplied by delta n minus k from k is equal to 0 till k is equal to infinity, right? And we need to set it. So you can just by observing this, what this indicates, as the k value changes, what happens? This particular, if I mean, like if I were to draw this particular part, let me just annotate it. Okay, you can see that this x of n has no k variable, isn't it? But you can treat this as a constant, right? So we are just left with the summation of delta n minus k from k is equal to 0 till infinity. If we were to plot that, right? So when delta, I mean, if you set the okay, okay. So if we start to plot this, right, the summation of this delta of n minus k from 0 till infinity, we'll have when k is equal to 0, you have a delta n that is basically a function f n is equal to 0, isn't it? And then when k is equal to 1, so basically this delta function shifts, isn't it, at 1. And then k is equal to 2, it shifts, right, isn't it? And all of these has an amplitude of 1, isn't it? And it keeps on going. So basically what you have is that you can rewrite this whole part, right, the summation s u of n. Okay, you getting it?
Yes, sir.
Okay, we have the calculation over here, right? So like I said, x of n, I mean this is the function that is given in our question, right? Okay, so from this we can see that there is no k variable in x of n, so we can take x of n outside, right? And then we are just left with this particular part. And the graph that I was just drawing is basically an indication that the delta function keeps on shifting as the k value varies, right? And we are summing it up. So basically this particular part, if plot it out, it just gives a value of 1, right? Starting from k is equal to 0, and just it keeps on going, isn't it? Right? Sorry for the sketching, right? But all of these are going to have the same amplitude. So what you can see is that this particular part is just a u of n function, isn't it? Right? So we can replace this particular part over here with u of n. Okay. Now, if we replace this with u of n, so basically u of n multiplied by any function is going to give me this u of n is an indication that we are only going to have values for n is equal to 0 and for n is greater than equal to 0, right? So this basically tells us that we have a value for x of n for n is greater than equal to 0. Otherwise, we have all zeros. So in place of x of n, we can write half to the power of n, and in place of u of n, I mean u of n is just there to indicate the limit, right? The starting and the ending point, right? So